fail. I'm gonna fail.
Time for Anova boot camp!
I'm so confused. I don't even get what an Anova is.
Well, an Anova is an analysis of variance, and you use it to compare several means.
Go.
Oh, so that means it's easier than using two sample t-tests several times and is more accurate. I get it now. Wait, now we're talking about f-tests? I thought we were dealing with t-tests. This is so confusing.
F-tests are used to compare several means, and the null hypothesis means that there is no difference between the means.
The alternate hypothesis means that there is some difference between the means, and not all means are equal. See? F equals the variation among several samples over variations of individuals in the same sample.
Wait, so it says df equals n minus I. I get that df stands for degrees of freedom. What are the other letters for?
Well, n is the total number of observations, and I is the number of simple random samples.
Great, now I'm finally ready to finish my Anovas.
No, you're not. There are some conditions for performing ANOVAs. First, you have to have several independent simple random samples with normal distributions. Then, you have to have either the same standard deviations or the largest standard deviation divided by the smallest standard deviation has to be less than 2.
Man, that was an interesting dream. I'm sure glad I have these voices in my head. Because now I understand Anovas. Thanks, guys!
Insert the information from each sample into a list. Then press the Stat button, choose Tests, and then select F Anova. Then enter all of the lists that contain the data and press Enter.
Sample problem. Bugs. To detect the presence of harmful insects in farm fields, we can put on boards covered with a sticky material and examine the insects trapped on the boards. Which colors attract insects best? Experimenters place 6 boards of each 4 colors at random locations in a field of oats and measure the number of cereal leaves beetles trapped. Here are the data.
Checking conditions of ANOVAs. It is given that the samples are randomly collected. When plotted in side-by-side stem plots, it is shown that the data have relatively normal distributions. The largest standard deviation, 6.725, divided by the smallest standard deviation, 3.764, is 1.8, which is less than 2.
Finding the degrees of freedom. There are I equal 4 groups, and n equals 24 observations, which is 4 groups at 6 observations each. Therefore, the degree of freedom equals n minus I, or the degree of freedom equals 24 minus 4, which equals 20.
Enter all the data for the separate colors into lists in your calculator. Press the Stat button, go to Tests, and then select F Anova. Then press Enter.
The calculator says that f equals 42.84, a very large f, with a p-value less than 0.001. Even with small samples, this gives very strong evidence that there are differences among the colors. Yellow seems to attract the most beetles, though.